All right, this is Honors Algebra 2 Pre-Calculus. We're doing 4.7. This is the third video in this section, and we're still doing inverse trig functions. So in this video, we're going to talk about solving two types of trig equations. One, those with no interval provided, and two, the kind that have a coefficient inside the angle. So, excuse me. Recall that a full circle in radians is 2 pi, and that if you add 2 pi to an angle, you get a coterminal angle, right? So with no bounds provided, basically you still find the same angles you were going to find, like we did in the previous video, but you to each answer you add 2n pi, meaning n full circles, right? Because 2 pi would be a full circle, so 2 pi n or 2n pi would be n full circles. All right, so we're going to find all solutions to this equation. So we're going to do the same thing we did before. We're going to recognize we're looking for where the y on the unit circle is 1/2, right? Which is going to be here and here, right? And then what we're going to do is we're going to say, cool, so that means that our answers are pi over 6 plus as many full circles as I want to add, and also 5 pi over 6 plus as many full circles as I want to add, right? Meaning that if pi over 6 is a solution, right, so this is pi over 6, then so is adding a full 2 pi to that would be a 13 pi over 6, right, etc., right? So basically saying that, that the solutions I would have found anyway, but I'm going to add 2n pi because no interval was provided, right? Let's go ahead and try another one. So you can try this one without me if you want. Remember, cosine is the x on the unit circle, so we're looking for where the x coordinate is a root 2 over 2. Again, you get better at this as you do it, but these are going to be the pi over 4s that are to the right of the y-axis, right? So this is going to be pi over 4, and this is going to be 7 pi over 4, right? And what we want to do is we want to list all of them. So we're going to say that theta is pi over 4 plus as many full circles as you want to add, right? Like every coterminal angle that could ever exist to that. And 7 pi over 4 plus, again, any possible coterminal angle that you could want, right? Because that's what that 2n pi does. All right, so for tangent, right, when we do tangent, there's a slightly different way to look at this, and we'll walk through it. There's two ways to consider the way that we're going to get the answer. So let's go ahead and walk through this first. We know that this means the y on the unit circle on top of the x on the unit circle, right? And so we're looking at this negative root 3 over 3, and that doesn't show up on the unit circle the way it is. So what I'm going to do is I'm basically going to unrationalize, because I recognize that there is no 3 on the unit circle, right? I unrationalize because there's no 3 on the unit circle. There's root 3, but there's no 3. So I'm going to unrationalize and realize that what this is actually looking like is a negative 3 over a 3 root 3, or a negative and then a 1 and a root 3. I then further recognize that there is no root 3 without the divided by 2 on the unit circle. So the way I'm going to deal with that is multiply both the top and bottom by 1/2, which I'm allowed to do. So I'm going to recognize that in reality, I'm looking at the x on, or the y on the unit circle on top of the x on the unit circle with opposite signs. That's what that negative tells me, where the y is a 1/2 and the x is a root 3 over 2. Once I know that, I say, okay, well, where y is a 1/2 and x is a root 3 over 2, those are the pi over 6s. But I want the pi over 6s that are in quadrant 2 and quadrant 4. Now, there's two ways to look at this answer. You can either recognize that this is a 5 pi over 6 and an 11 pi over 6, right? And you could write your answer as theta equals 5 pi over 6 plus a full circle, which would get you all the coterminal angles to 5 pi over 6, and an 11 pi over 6 plus a full circle. That's one way to write the answer. This is okay. But there's also an easier way to write this. So this is okay, but there's another option here. Because this is a tangent, the period of tangent actually isn't 2 pi. The period of tangent is pi, and it's not an accident that this is a linear pair. These two angles make a line together. So I could just write this as a 5 pi over 6 plus n pi, because I went from 5 pi over 6 and I added pi. And then I added pi again, and I added pi again, and pi again, and I'm going to get those same two angles. So this would also be an okay way to write it. Either of them would be fine. If it were multiple choice, you could see either. So you should just be aware that they're the same answer. Again, what makes this special is that these two values are pi radians apart, right? They make a straight line, as opposed to these, where obviously they do not make a straight line, and this, where, again, obviously not a straight line, right? So anytime you essentially have answers that make 180-degree angle or a pi angle or a straight line, however you want to think about it, you could use that trick. So let's go ahead and try another one. Let's do cotangent of theta is 1, right? So this is basically saying the x on the unit circle on top of the y on the unit circle is a 1. So the x is the same as the y. Well, that only happens in 2 places. It happens here at pi over 4, where both values are root 2 over 2, and it happens here, exactly pi units away, for the record, where both of those values are negative root 2 over 2. So my answer could either be written as theta equals pi over 4 plus 2n pi, meaning full circles, and also 5 pi over 4 plus 2n pi. That's one way to write the answer. That's totally okay. But the other way you might see this answer written is you might see it as just the pi over 4 plus n pi. Instead of adding full circles, you're adding half circles. So either of those ways to write the answer would be fine. Again, notice that this is a straight line, right? Like this is a linear pair, it makes a line. All right, so next we're going to do angles where there is a coefficient b inside the angle. So this is actually the value that we've seen before that is called the frequency and changes the period of a function. So if an interval is provided, you're going to need to go b times around the interval to find all the solutions. So for instance here, b is 2. If there had been an interval provided, I would have to go twice around the interval to find all the solutions. If one is not provided, then you're just going to find all the answers in the typical 0 to 2 pi window and add 2n pi to each of those answers. Once you find those angles, you're still going to need to solve for the variable, which usually means divide all your answers by b. Sorry, there's a missing parenthesis. So let's go ahead and walk through some of these. So we're going to find all solutions to this equation. So notice that this b is 2. So first thing I have to ask myself is where is the y on the unit circle equal to a root 2 over 2? Because that's what sine is, right? Sine is the y on the unit circle. So that's going to be here at pi over 4 and here at 3 pi over 4. Since there's no interval given, I'm going to say that my angle, which is 2 theta, is either a pi over 4 plus 2n pi or a 3 pi over 4 plus 2n pi. The problem is that I haven't solved for theta yet, so I'm going to have to divide literally everything here by 2. So what's going to happen is I'm going to get that my theta is a pi over 8, because that's what happens if you cut a fourth in half, right? Pi over 8, plus a regular n pi, not a 2n pi, and a 3 pi over 8 plus an n pi. And those are going to be my answers. So those are my 2 answers. Again, notice I'm dividing not only the angle I found, but also the plus 2n pi by that too. All right, so you're going to go ahead and give this a try. Again, no interval is given. So the first thing you have to ask yourself is where is the x on the unit circle equal to negative 1/2? Well, x's are negative to the left of the y-axis, and the x's are a half at the pi over 3's. So these are my 2 answers. So basically, I'm going to get that 3 theta equals either a 2 pi over 3 plus 2n pi, or a 4 pi over 3 plus a 2n pi. And then I'm going to have to divide the entire thing by 3's. So I'm going to get that my theta is either a 2 pi over 9 plus 2n pi over 3, or a 4 pi over 9 plus a 2n pi over 3. And those are my answers. All right. So now the last 2 are going to be ones where we have intervals so that you can see what this looks like, and then we'll have one more video after we finish this one. All right, so now we're doing the 0 to 2 pi, right? We're going to find all the values that satisfy this equation. Notice that b is 4, so I'm going to go around this interval 4 times. So I have to ask myself, where is the y over the x on the unit circle equal to a negative 1? And hopefully we're getting pretty good at this, that we can spot when a tangent is negative 1. Tangents are negative 1 in these 2 quadrants at the pi over 4's, right? So basically, I'm going to go around this interval 4 times. So time number 1, I'm going to get that this is a 3 pi over 4 and a 7 pi over 4. So that's my first trip around the circle, right? That's trip number 1. Trip number 2, right? Trip number 2 is going to mean adding 2 pi to each of these, adding a full circle to each of these, right? Now you can kind of cheat here because it's a tangent, and you could, there's a way to cheat in a sec that these are pi units off, and we'll talk about that because, again, tangent's a little bit different. But we're going to do this as though we didn't spot the tangent trick first, and then we can go back and talk about it. So if I add a full circle, right, in pi over 4's, right, a full circle is 2 pi, which is 8 pi over 4, right? So that's worth noting. So when I add a full circle, I'm going to get, this is an 11 pi over 4, right, and a 15 pi over 4. That's trip number 2 around this circle, right? When I then go around a third time, I'm adding another full circle to each of these, so that should be a 19 pi over 4 and a 23 pi over 4, right? And then when I take my last trip around this circle, so that was trip number 3, right? But I'm going around 4 times because b was 4. My fourth trip around the circle, I'm going to add another 8, right? So I end up with 27 pi over 4, and then another 8, which would be 31 pi over 4, right? So all of that, and then once I have the full list of those values, I have to divide every single one of these things by 4 to get the answers. So I'm going to end up getting that theta is a 3 pi over 8, right? A 7 pi over, oh, not 8/16, my bad, come on, brain. Sorry, 4 times 4, not 4 plus 4, come on, brain. 3 pi over 16, a 7 pi over 16, and 11 pi over 16, right? Because it's cutting a fourth in 4 would be dividing by 4 again, so that's 15 pi over 16, 19 pi over 16, 23 pi over 16, 27 pi over 16, and 31 pi over 16. Now let's say that you were skeptical and you're like, Hogan, how do you know that I'm supposed to go exactly 4 times around this circle? Well, if you didn't believe me, try going one more time around this circle. And remember, a full circle is 8 pi over 4, but in 16ths, it would be 32 pi over 16, right? So see how this is still in that 2 pi window? If I had gone around one more time, right, if I'd gone around a 5th time, which I'm not supposed to do, I'd end up with a 35 pi over 4 and then another one after that. Well, look what would happen if I had a 35 pi over 16. It's too big. It's not in the window, right? So the window was 0 to 2 pi, and this does follow the window of 0 to 2 pi. So again, the trick of going around 4 times is just sort of like a helpful thing. So what I was saying about the hint with the pi's is if instead of adding 2 pi over and over again, you could have just noticed that to get from 3 to 4, to get from 3 to 7, you add a pi and then a pi. And so I ended up, by the end, although I wasn't saying it out loud to you, I was just adding 4 to each of the numerators because I noticed that these are pi units apart. So I was adding 4 pi over 4. But again, what you're really doing is going the full circle, the 2 pi, like whatever this whole interval is, you're going around the interval 4 times because this is a 4. And so it helps me personally to number those and say, hey, did I go around 4 times? All right, so we're going to try one last example in this video, and then we'll have another video after this. So find all values from 0 to 2 pi that satisfy this given equation, right? So again, what I'm being asked here is when is the x on the unit circle over the y on the unit circle equal to 0? It's helpful to know that. So if you multiply the y over, this is basically just saying where is the x on the unit circle 0, and conveniently that's just here and here, right? I'm going to have to go around the interval twice because of the 2. So I list that 2 theta is equal to, well, the first time around I'm going to get a pi over 2 and a 3 pi over 2, right? That's my first trip around this circle. My second trip around, I'm adding, so remember that a full circle is 2 pi, but in pi over 2s, that would be 4 pi over 2, right? So that's what I'm adding. So the next time around should be a 5 pi over 2, right? Because that would be the pi over 2 plus a full circle, right? And then the last one would be a 7 pi over 2, because again, that's the 3 pi over 2 plus a full circle. So those are my 4 answers, right? I went around the circle twice, so first time in red, second time in blue. And then I'm going to solve for theta by dividing everybody by 2. Remember, cutting a half in half is like having a fourth, right? And that makes sense because remember that dividing by 2 is the same as multiplying by 1/2, right? So if you multiplied a pi over 2 by a 1 over 2, you'd get a pi over 4. So I'm going to get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, right? And that makes sense because, again, if you're not sure if you went far enough, if you said, oh, Hogan said go around twice, but I'm not sure if I went around the right number of times, if you had gone around one more time, right, you're not supposed to, but let's say you had, you would have gotten a 9 pi over 2 as the next item. Well, 9 pi over 4 is too big, right? That's greater than 2 pi, and my window is only supposed to go to 2 pi, right? So that's kind of the idea. 9 pi over 4 is bigger than 8 pi over 4, so it would have been too big. So if you trust me that when you see a 2 in here, it means go around the interval twice, right? So whatever this interval is, I go around it twice. That's always going to work. If you don't trust it, you could just go around a bunch of times, and then what you're going to find is you end up crossing off all the answers at the end that are too big. All right, and that is it for that video.